It's been known for years that developing fetuses will grow vestigial organs and other structures, which will then dissolve or break down sometime before birth. At an early stage in development, the hands and the feet have a primitive webbing. Rudimentary gill-like structures form along the neck, and perhaps the most well-known example occurs in the first month of embryogenesis, when human fetuses develop a tail. Within a few weeks, the tail will dissolve into the much-reduced coccyx, which we retain as a remnant of our evolutionary past, of our ancient ancestors who did have tails. Taking a step back to appreciate the larger context, if we compare a very early human embryo with the very early embryo of various species of bird, fish, reptile, or any other mammal, all of these embryos look remarkably similar. This embryological similarity across the vertebrate clade is a powerful callback to our shared evolutionary origins. Now, a new study has identified yet another structure that calls back to some of our earliest vertebrate ancestors. This study, published in the journal Development, analyzed a set of ephemeral muscles that appear in the fetus's hands. Here's a passage from the abstract of the study. Quote, "Our study confirms the transient presence of several atavistic muscles, present in our ancestors but normally absent from the adult human during normal embryonic human development, and reveals the existence of others not previously described in human embryos. These atavistic muscles are found both as rare variations in the adult population and as anomalies in human congenital malformations, reinforcing the idea that such variations/anomalies can be related to delayed or arrested development. We further show that there is a striking difference in the developmental order of muscle appearance in the upper versus lower limbs, reinforcing the idea that the similarity between various distal upper versus lower limb muscles of tetrapod adults may be derived." Unquote. So what they're saying is that as the fetus develops, these atavistic features, or features that relate to an ancestral form, these features will emerge, and then sometime later dissolve or disappear. Or they will establish the base tissue upon which more derived structures can be built. But if there's a problem during development, if these developmental processes are impaired or interrupted, these atavistic features can be retained, which interferes with healthy development and can lead to deformities. Then they point out how the order of muscle development, as in the sequence in which certain muscle groups or tissue layers emerge, is different in the forelimbs and the hind limbs, and these differences between hands and feet are hugely influential in the ultimate physiological utility of each limb. This is why your hands are more dexterous and more manipulative than your feet. This is why your hands and your feet are different. They're similar, but they're ultimately different structures that can do different things. Their evolution has derived different developmental processes to create, ultimately, different mature structures. In this case, your hands with your long, flexible, dexterous fingers, and your less dexterous feet with their stubbier, less flexible toes. Now, the specific muscles identified in this study, called dorsometacarpales muscles that exist in the hands, have been conserved for more than 250 million years, which means that they would have emerged around the time that proto-mammals diverged from archaic reptiles. These muscles are present in the hands of a human fetus from about week 7 to week 13 of gestation. These muscles will appear attaching to every finger, but then they'll disappear from every finger, except for the thumbs. These muscles will stay on the thumbs, and the researchers argue that this preserved collection of additional muscles are what gives the human thumb its remarkable dexterity. The study authors point out that they also see similar muscles appear and disappear in the fetus's feet as well. This is really cool stuff, and I find it extremely fascinating. Studying the nuances of fetal development is like looking into a portal to the distant evolutionary past. We can literally see the remnants of evolutionary processes and features that existed in our ancestors, but have since been lost. In a really cool, kind of biochemical, anatomical way, The emergence and embryological development of each individual involves processes that call back to the evolutionary emergence of our species, to the evolutionary development of our clade. And that, really, that is just incredible.